Hello, everyone, and thank you for joining us today. In this webinar, we will be covering an introduction to IO-Link for end users and device vendors. My name is Nelia Young. I am part of the PI North America team. Today, I will be presenting part of the material and moderating the session. Our main speaker of today is Michael Baum. Michael is the Executive Director at Profibus and Profinet North America. Just a few items before we get started. Please do not hesitate to use the chat function or the Q&A section in the GoToWebinar panel to submit any questions, or maybe if you're experiencing technical difficulties, please let us know so we can try to resolve those. Thank you again for joining us today, and let's get started with the content. First, I would like to introduce the organization behind the technology. Profibus and Profinet International, or PI, is the international creator, maintainer, and promoter of open industrial communication standards. It was founded in 1989, and Profibus, Profinet, and IO-Link make up the portfolio for the technologies that the organization covers. The PI organization has an international emphasis, and it has sub-organizations all over the world, including regional PI associations. So for example, I am part of PI North America, but there's also an organization in Spain, Brazil, Denmark, Japan, and so on. We also have PI competence centers. This is where you can find technology experts. There's also PI test labs. This is where products get tested and certified. PI training centers, where you can get further training in a specific technology, either if it's certified or uncertified, or for developers. PI North America is one of those regional PI associations. We were founded in 1994 as the PTO, or Profibus Trade Organization. And then we have rebranded ourselves as Profibus and Profinet North America. We're located in Scottsdale, Arizona, but we really cover the whole North American region. We're a nonprofit and member-supported organization. So we literally have nothing to sell you, but we just bring this information to you. Currently, we have over 150 members that include device manufacturers, system integrators, distributors, machine builders, end users, and more. Thanks to our members is that we're able to bring all of these educational programs to you. The sponsors of this particular webinar are the following. Thank you so much for your support. Now, let's get started more in the topics with IO-Link, starting by introducing the IO-Link Consortium. IO-Link is the first IO technology for communicating with sensors and actuators that has been adopted as an international standard. The great interest of IO-Link has generated an extensive community. Currently, there are over 330 companies from automation and communication industry that are part of the community. You can find component manufacturers and technology providers all around the world. And this is very important. The organization is Fieldbus independent, even though the IO-Link is attached to PI organizationally. The technology is meant to be used with a vast variety of field buses. There's many different working groups within the consortium, and various companies make up these working groups. So technically, any member can end up influencing the direction of the technology and its marketing. The IO-Link community takes many different initiatives and tasks. For example, it of course takes care of the technology and the standardization of IO-Link and any updates. It also takes care of public relationships and press. They also cover marketing activities and promotional activities, such as attending to fairs, making webinars, workshops. So in terms of education, they also play a crucial role. They also take care of the website and the media within iolink.com, including documentation, technical documents, and training. They also cover customer requirements collection and any new initiative that might arise. By joining the community, you are able to participate in a wide range of initiatives that takes care within the community. So we just mentioned the community aspect, but it is also of extreme importance that we mention the specific components, the products, and the availability of these components. Currently, in terms of IO-Link masters, there are 16 different field bus systems that have been adapted for IO-Link masters, including 21 manufacturers that offer central PLC masters. For IO-Link devices, you are able to find over 23,000 IO-Link devices in the IODD Finder. If you're not familiar with this finder is a service of the IO-Link community. It's a centralized multi-vendor database for description files for IO-Link, plus the script products. And because it's multi-vendor, you're able to find over 100 device manufacturers represented within the Finder. Later in the presentation, Michael is going to expand on on how the Finder works and even show you what are the specifics. In terms of technology, currently there are 31 manufacturers that offer IO-Link technology for product design. So if you're interested in developing products that include IO-Link, this is of crucial importance. We'll also cover information about development later in this presentation. And there's also 22 companies that provide technical support and services for engineering. In terms of adoption of IO-Link, I wanted to show you this graph here today. As of 2020, according to the PI node survey, there were 21 million IO-Link nodes installed worldwide. From 2019 to 2020, 5 million nodes have been added. This is a growth rate of 31%. And the adoption of IO-Link really continues to grow rapidly and continuously every single year. This fact is encouraging not only for the manufacturers, but also for the end users, as more and more products also become available. Now let's get more into the details of how IO-Link works, its features, and its functionality. In the past, most automation networks were highly characterized by a hierarchical structure, where we had automation on one side and business processes on the other side. We had the field in the bottom, and then it continued into process and control, then MES systems with production, operations with ERP systems, and the executive level on top. And those lines between each section didn't really blur. Nowadays, we're seeing a trend going towards converged networks, where it's not a hierarchical system anymore, but it is an interconnected mesh of components that connect with each other. So we're actually seeing field devices directly connected into MES, ERP systems, or even the executive level. And this is where IO-Link plays a role. Based on the classic automation pyramid, we had the field bus with the respective higher level systems with the controller, with the IO, and the field devices. But in this case, communication only reached the IO level, or maybe some complex field devices. All the simple standard sensors and actuators were inaccessible communicatively. With IO-Link, this changes and makes a shift for the better. Now, with IO-Link masters and IO-Link devices, now we are able to have access to these simple sensors and actuators that are communicatively accessible. Communication goes down to the field level, and there is a sense of transparency from the field all the way into higher level systems. Before we get into further detail of the features and functionality of IO-Link, I'd like to share with you a quick poll. This poll will help us understand you better and what audience is here today in this webinar. So if you will please answer this poll. It's about how familiar are you with IO-Link and what is your experience if maybe you're just getting started or maybe you already have a little bit of experience but are looking to get a bit of a refresher. I'll leave it there for a few more seconds. All right, I'm going to be closing the poll now. All right, well, thank you for your feedback. The vast majority of you, over 50%, are just getting started with the basics, so we'll try to target the material in between the basics and also a little bit more advanced as we go through the presentation. Now, I would like to switch the controls to Michael Bound. He'll be continuing the presentation. Hello, Michael. Welcome.
Hello, everybody, from my side. Once again, thank you all for participating today. Let me grab my slides. You can all learn about IO-Link features and functionality. So, a IO-Link system consists of basically 4 components. The IO-Link master, which represents the interface between the IO-Link devices on the lower level and the communication system on a higher level, whether this is a field bus, whether it's an industrial Ethernet, or a backplane if it's connected directly to a PLC. The second component are your IO-Link devices. These is your bread and butter IO-Link sensors, actuators, signal lamps, whatever the case may be. These are connected to the IO-Link master via a 3-wire unshielded standard cable. This is the standard connection between an IO-Link master and a device. And the fourth piece of the puzzle is an IODD, or IO-Link device description file. And these are used to set up and parameterize your IO-Link systems and devices in the, let's say, the engineering tool of the PLC. And we'll talk more about all of these in details as we go through. So as I mentioned, on this interface with IO-Link, it's a 3-wire interface, 2 wires providing your power, and the third is the actual IO-Link interface, which is a serial bidirectional communication. And as you can see in the top half of the slide there, we're using a standard M12 connection. Pins 1 and 3 are our power, and then pin 4 is what's known as the IO-Link communication, or SIO, which we'll talk about in another second. You can send 200 milliamps max of current device via this way. Sensors typically use a 4-pin M12 connector, type A. Pins 2 and 5 are not predefined and freely assignable by the device manufacturer. Maybe they want to use it separately for a DI or DQ. In the case of actuators, they typically use a 5-pin M12 connector in type B. And what this allows them to do is to use pins in 2 and 5 for an additional supply voltage. So in many cases, you have actuators that need a little bit more juice, and so they can do that both over pins 1 and 3, and then also additionally over pins 2 and 5. But at the bare minimum, it's a 3-wire unshielded standard cable that many are already using to connect their quote unquote stupid or quote unquote analog, or their analog sensors or actuators that they've got out there. If we zoom in on that IO-Link communication done over pin 4, there are actually 2 different modes that a device can communicate over. In the IO-Link mode, obviously it's using IO-Link communication, but there's also a so-called SIO mode, or standard IO mode. And in this case, the port of the master behaves like a digital input, and the sensor behaves like a binary sensor, so 0 or 1s. In the case of an actuator, the master behaves like a digital output. And actually all IO-Link sensors actually start up in SIO mode to start. And then the minute they're connected to a master that's in IO-Link communication mode, they go through a wake up and then begin communicating via IO-Link. We're not going to get into the bits and bytes of how an IO-Link frame looks like. That's a little bit outside the scope of this introduction. And for many that are installing IO-Link in their plant, they don't really need to know that down at the bits and byte level. because it's so easy to use, so easy to install, so easy to configure that you don't really have to get down to that bit and byte level. Same thing with wake ups. We don't need to get to that deep level because you just basically plug and play, and this stuff starts working right out of the box. IO-Link can be transmitted over one of 3 transmission speeds that it supports, all the way from COM1 at 4.8 kilobaud up through COM3, 230 kilobaud. And it's key to mention that all 3 transmission speeds are supported by all masters, but not all devices support all 3 comms. The device transmissions, the transmission speed that a device supports will be specified in its IODD file, and we'll show that in a minute. And then, as well as the minimum cycle time that the device can support is also stored in the IODD file, and this is how often the master may address the device. And it depends on the technology, but typically you can expect to achieve cycle times of 2.3 milliseconds at COM2. Also critical to note is that the cycle times and transmission speeds can be set independently per device. So if a master is speaking to a temperature sensor, which has a value that isn't changing particularly rapidly, it doesn't necessarily need to address it every 2.3 milliseconds. On the other hand, if it's also addressing a proximity sensor where that data is super time critical, then it can do that. And so this can all be configured in the engineering tool via the IODD file when the IO-Link system is set up. Again, we're not going to get down into the bits and bytes of an IO-Link frame, but IO-Link data comes in 4 broad types. You have your process data. This is the piece of data that you're actually interested in, what the sensor or what's being sent to the actuator will be doing. You have a value status, whether the process data is valid or invalid. And this can be transmitted cyclically with the process information. You have some device data. This is acyclically transmitted at the request of the IO-Link master. And then finally, you have events, which would include alarms, things like that, which are pushed from the IO-Link device to the master. And so here's another way of looking at it based on the origin, the data type, and the data display. We've taken out the value from the type column here because that's standard for all of them. But the reason we've organized it like this, based on the origin, the type, and the data display, is because if you look at the right-hand column with observation, identification, and parameterization, this is actually how the data is organized in an IODD file. And so when you're doing configuration, you're interested in the identification and parameterization part of things. When the data origin is an alarm, here we're talking about events, and therefore the data display would be the diagnostics. And of course, the bread and butter IO-Link operation data origin is operation, which is the process data, and this is the observation. So where we're looking at the data and interacting with it. So how do you set up and configure this identification, parameterization, and how is all of that done? Well, on the one hand, you have your IO-Link masters. So these are field bus specific, and so they will have their own station description, whether it's a GSD file, an ESC file, EDS file, or XML file. The data is collected in the IO-Link master. It's from all of the IO-Link devices below it. So maybe it's a 8-port IO-Link master, or it could be a 16-port IO-Link master, or it could have an IO-Link hub connected to it, and then you have really quite a number of devices that are connected to that IO-Link master. They're collated all together and sent out the other side via whatever industrial Ethernet or field bus is connected to the IO-Link master. So that's the one hand. So that's the master side upwards. And then the IO-Link devices and their connection with the IO-Link master, those are configured with an IODD file, which we'll show here in a second. And you'll use an IO-Link tool for that. Many engineering tools that configure the PLC also include an IO-Link tool that allow for the configuration of IO-Link devices via the IODD file. And so as Nelly mentioned earlier, we have these IODD files that are in what's called the IODD finder. And so here we have a typical example of an IODD file, what you can expect. It's a zip package that contains not only the XML information, but also a picture of the device, an icon of the device, the manufacturer logo. It tells you what the parameters are, what the value ranges are, what the data types, how long is the process data, what is its structure. All of this information is available. And so the best way to learn something is to actually do it. So what we'll do now is we'll pull up the IODD finder. This can be found at the iolink.com website. On the right-hand side, we click on IODD finder, and then we open it here. And so let's look at an IOLink device. I'm going to pull up this. This is a reference design. So this isn't actually something that you would install in your factory. It's just a reference design if you're testing, but it is an IOLink device, and therefore it has an IODD file. And so you can see the overview. It's got a device ID. This is unique, and it's set by the manufacturer. Here's the logo. Here's the device picture, and all of that comes in the package when it's downloaded, when it was uploaded, what IOLink version it supports. And new as of earlier this year, they've integrated an IODD viewer, which we will now look at. And the IODD viewer gives you a easily viewable representation of the information that's in that IODD file, that IODD XML file. And as you can see here on the left-hand side, we're back to talking about identification, parameterization, and observation, because again, that's how they're organized in the IODD file. So you can see the transmission rate that's possible. You can see the minimum cycle time that this can be addressed, what to expect on the data input side. If we hop over to identification, gives you some read-only, as you can see here with the RO, read-only information about the vendor. It'll have a serial number, hardware revision, firmware revision. Under parameterization, these are read-write parameters. We're parameterizing the resolution of this temperature value because this is a temperature sensor reference design. So whether it's 8-bit, 9-bit, 10-bit, or 12-bit, you can parameterize a switching point if you choose, hysteresis, do a factory reset, things like that. And then finally, under observation, this is the actual data that you can expect. So here's the temperature data, whether there's an over temperature status. Again, these are both read-only. But then really interestingly, are all these other little bits and pieces of information. And this is kind of the beauty and the power of IOLink, and it speaks to the whole Industry 4.0 and industrial Internet of Things, is that this isn't just providing a temperature value, but it also can provide other information, semantics and things that go to preventative maintenance and condition monitoring. For example, how many operating hours, how many power cycles, what's the average temperature? If you're doing a conversion rate on the temperature, what is that? So all this extra rich data, all this extra rich information is what really provides the power of IOLink that maybe a traditional sensor wouldn't provide. And so as we mentioned before, this is all on the IODD Finder website at ioddfinder.iolink.com. And the way it works is the IOLink device vendors upload their IODD files. And then as we've shown, they can be accessed via the web or via an app. But in most cases, the vast majority of interaction that happens with the IODD Finder is via API through IOLink tools. So somebody has got their PLC on a workbench and they're setting up their IOLink devices. They add it to their network, let's say, and then the configuration tool will say, hey, where's the IODD Finder? Would you like me to go out and grab it? Where's the IODD file? Would you like me to go out and grab it from the IODD Finder, which it then does automatically, and then you can start configuring devices. And that's how most interface happens with the IODD Finder. Is really behind the scenes that most people don't know about, but it is there available if maybe your PLC is not connected to the internet, which is, for security purposes or whatever the case may be. You could go to the IODD Finder, download it, and install it into your configuration engineering tool traditionally. So that's some of the features and functionality of IOLink. Let's jump into the benefits of actually using it. And we thought that the best way to do this would be to give an analogy. And the best analogy for IOLink is, from a benefits perspective, is like that of of USB. So the reason USB has become so ubiquitous is just how easy it is to use. You plug it in, everything works. There's one cable for all the device, and the same is true for IO Link. You have a unified unshielded 3-wire sensor cable for each IO Link device. The connection is standardized with M12, and everything just happens when you plug it in. And so some benefits of the wiring until now: smart devices, which is what we're talking about with IO Link, often required multi-pole cables, so the wiring is time consuming. They had different cable specifications, shielded, unshielded, how many wires, so on and so forth, and therefore the availability and warehousing become more difficult. And then multi-pole cables are large and expensive to install, whereas in the case with IO Link, quick installation is done with a M12 plug. Spare parts are reduced because we have a uniform cable, and then installation and maintenance is easy because it's a thin and flexible unshielded sensor cable. The second parallel between USB and IO Link can be seen in the identification and parameterization of the devices. Once a USB device is connected, it can be detected and identified immediately. Software tools are then available for parameterizing it. And then IO Link devices can be detected and identified when connected via parameter information, for example, how we use a vendor ID or device ID. And similarly, parameterization tools are available, so software interfaces can be used with the help of an IODD and the associated device. So just like when you plug your printer in to your computer, it automatically identifies it, says, okay, I see what this is, and then you can start the parameterization part via a software tool. The same is true for IO Link. And until now, parameterization of intelligent devices could be quite complicated because it was non-standardized, and therefore individual training was necessary. If you're going to change formats, things like that, it required stopping the machine to change parameters directly on the device. And then similar devices cannot be exchanged without parameter adjustment, as parameter ranges are often too large. But with IO Link, if, let's say, a device is replaced, those parameters are automatically downloaded from the master to the device. No special knowledge is required. Format changes can be done. Maybe instead of reading in one type of temperature, you want to, instead of Celsius, you want it in Fahrenheit or something like this, can be done typically via an HMI directly on the machine without having to stop it. And then identification prevents the use of unsuitable devices so that you're installing into the correct place a sensor that is appropriate for what it's supposed to be measuring. Diagnostics are also similar to USB. So for example, if your printer runs out of paper or toner or there's a paper jam, you are notified immediately and right away. You don't have to pull out the manual for the printer to figure out what's wrong. It gives you something in plain text. You can see it right away. And then that's the same is true for IODD files, because all of that is in plain text. You know exactly if there's an under voltage, an over temperature, maybe the signal has been degraded. So until now, diagnostics were difficult to get down to at the device level because you'd have to be directly on site at the device to do those diagnostics. Sometimes an individual line test is required to find a fault, so localization is difficult. And in order to avoid downtime, you have to do manual preventative maintenance or manual condition monitoring, or replace the device. It's a break-fix model. Whereas with IO Link, diagnostics are known immediately. They're known very clearly and plainly what the diagnostic is. Since it's standardized, localization is possible of the error very quickly. So you know exactly what, who, where, when, why, and how. And then finally, it goes to this greater movement from break fix to preventative maintenance model that many companies are looking, because downtime costs more than any one thing on the factory floor. And so if we know that the valve has performed some number of actuations and it's going to fail after a large number, we're approaching the limit of the number of actuations that the valve can handle before its lifetime is up, then we can replace it when there's a planned downtime instead of waiting for it to break and then fixing it. There are some benefits in general to digital communication. Until now, measuring sensors have been used that would amplify the signal from a device, convert it to a stable digital signal using an A to D converter. That signal was then processed, linearization, temperature compensation, etc., in order to display the measured value as accurately and as stable as possible. After this stable and highly accurate value, the question comes, well, how do you transfer it to where it's needed? In many cases, that's the PLC, traditionally. And then for this purpose, that laboriously generated digital value was then converted back into an analog value in order to be sent over a 0 to 10 volt connection or 4 to 20 milliamp or similar format over a shielded wire to the controller, where it's then converted back to a digital value by an expensive analog card in the PLC. And of course, this is just, frankly, a little bit ridiculous because of the time and the expense involved in doing that, of the cards and the cabling and not knowing if there's interference on the line. So with IO-Link, you use a sensor cable instead of a shielded specialized cable. The transmission is basically interference proof. You reduce the costs because you don't need that expensive analog card on the PLC side. And then of course, the real benefit are in the extra data that you get from quote unquote smart sensors with parameterization and diagnostic channels and all the stuff you get for free with IO-Link, which is the real power behind it. So we've covered the features and functionality of IO-Link, talked about some benefits of using it as compared, as related to USB. What we'd like to do now is jump into what's new. So what's been going on in the IO-Link community in the past couple of years that's really exciting stuff and causing IO-Link to be used in new and different use cases. And so the best way to do that, we thought, was to actually show the use cases, give an example of some applications where IO-Link is being used, and then relate them to the new features and available features that are available in IO-Link. So the first one comes from a non-traditional setting. Let's say this is an example where you have a weather service. This is a real example. Weather service requires the temperature and snow height data from a remote measuring point in the mountains. But unlike in a classical installation, let's say of IO-Link, there's no PLC and there's no field bus or industrial Ethernet at all involved in this. And what the requirement was is to get that data from the IO-Link sensors directly into the IT world. So for example, in a cloud server, where it then could be accessed globally from anybody or anywhere. And the solution here is to transfer the IO-Link data over MQTT. So the IO-Link master has a data server on it, which sends the updated measurement value as JSON. So it encodes the data in JSON, sends it over MQTT to an MQTT broker. And then those that are subscribed to this MQTT broker have access to the data anywhere, everywhere that they can get it. So this is the quote unquote publish subscribe model. This is a real world example that doesn't have a PLC, doesn't have a outside of traditional industry, and so that's pretty cool. And the way this works is with an IO-Link to JSON companion spec. So it provides a seamless and easy connection of IO-Link to the cloud. JSON is widely accepted in the IT world, really well suited for IoT applications. And then this can be done either via request response, in which case the mechanism is HTTP REST, or as we showed in the example, this can be done in a publish subscribe model via over MQTT. Either transport is possible. And this has been published since January of 2019. It's not just a spec though. I mean, this is real world. There are IO-Link masters available, freely purchasable on the market that have this MQTT capability and JSON capability built into them. And so it's simply a matter of finding the right products and connecting it all up, as both JSON and MQTT are both widely used in the IT world. So this is a little bit of a more traditional factory automation application, where during the installation of a gearbox, the tightening torques that are used need to be evaluated and stored for quality management. And so again, the requirement is to get that data from IO-Link, but this case, instead of sending it to some cloud application, you're still using a traditional controller with a traditional field bus or industrial Ethernet protocol, but this time linking it to an MES or an ERP system. So the way it works is the IO-Link master contains an OPC UA server. And since OPC UA has become really widely adopted in the industrial automation space and has become almost a bit of a de facto standard for connecting, the factory floor to the higher level systems like an MES or an ERP system, OPC UA is great for information models. So that IO-Link information can be modeled in an OPC UA information model, and then everything understands it. It's human and machine readable. You can send these device parameters even with OPC UA. You can configure master devices with OPC UA, and you can interpret these parameters because of the companion spec. And this has been available since the end of 2018. And like we said before, it's standardized data access to IO-Link from basically any OPC UA client. It's manufacturer independent because it's a companion spec. That data will always come in the same way, always look the same way, have the same semantics, so on and so forth. And then again, this is not just a companion specification, but there are plenty of IO-Link masters on the market that on the one hand are both an IO-Link master, so they talk to the IO-Link devices below it. They also speak field bus or industrial Ethernet for the automation related information. And then on the third, they also speak OPC UA to connect to higher level systems. And so this is real world stuff. And if you're in a traditional manufacturing factory automation setting, this is how you'll probably want to use and connect to IO-Link systems from higher levels. The third use case has to do with a typical application of a tool changer on a robot arm. So in this case, you have multiple sensors and actuators which can be located on the tool, but they all must be individually wired to the controller through the robot arm. And therefore, this individual wiring requires a really complex and therefore expensive adapter with lots of lines, and so lots of cabling and quite some expense. And so what you need is a reduction in cabling while making sure that the data transfer is really, really robust. And so the solution in this case is what's known as IO-Link wireless. Multiple devices can communicate with an IO-Link wireless master at the same time. Therefore, the adapter can be really, really simple. All it needs to do is provide power to the wireless devices. And then the process data is transferred cyclically. The data is transparent. Parameters, everything the same benefits of IO-Link over a wire we have with IO-Link wireless. And so this IO-Link wireless system extension was released in March of 2018. It uses a really cool technology in the 2.4 gigahertz ISM band, and it does some really neat things with frequency hopping such that it's super, super robust. So the error probability is 1 in a billion. So that data is going to get there. It can go up to 20 meters, similar to wired IO-Link. Up to 120 wireless devices can be connected to a single IO-Link wireless master. And the cycle time is also very, very fast at 5 milliseconds. So for many, many installations, this is possible where maybe you have data transfer between mobile units, or there's limited wiring space. You could install this. You want to go through a slip ring. Well, in this case, IO-Link wireless makes a lot of sense to you. So there are a lot of applications. And again, this is available from from a number of different manufacturers that make IO-Link wireless masters and IO-Link wireless devices. And the fourth thing that's new in the IO-Link world has to do with functional safety. So on the left-hand side, you have a traditional functionally safe remote IO connected via some functional safety communication protocol, whether that's SIP safety or ProfiSafe or FSOE or whatever the case may be. And in that IO, you have some functionally safe AIs, maybe connected to via 0 to 10 volts. You have some functionally safe analog outputs. You have some functionally safe DIs, maybe that's an e-stop button or light curtain or similar. You have some functionally safe DOs, maybe that's sending signals to relays that then have to do whatever they're supposed to do when the safety signal is actuated. But with IO-Link safety, all of that hardware gets eliminated. You have one functionally safe master, and then it simply communicates IO-Link safety to all of these sensors and devices. And then in the case of, instead of relays, you have intelligent actuators or intelligent drives that can handle an IO-Link safety signal and really implement a little bit more complex safety scenarios like safe torque off and slowing things down instead of stopping them altogether and killing power, things like that. And this of course can be either at remote IO as shown here, or it could be simply a functionally safe card on the PLC. So similar to IO-Link standard, you have a backwards compatible mode. This is OSSDE in the same product. So if it's connected to a traditional maybe DI, then it functions in OSSD mode. Where if it's connected to an IO-Link safety master, then it starts communicating via IO-Link safety, obviously. And you're transmitting both safety and standard data on the same IO-Link connection, so no separate wiring is needed. No dip switches need to be set for addressing. No watchdog time needs to be calculated. This is all done automatically. You can exchange a device without using a tool. It's device replacement is plug and play. And then it's the same IO-Link cable, so up to 20 meters, flexible without shielding. So those are some of the 4 new things that have been going on in the IO-Link community over the past couple of years, and it shows really the breadth and depth of the technology and the different applications. So what I'd like to do now is shift focus a little bit. A lot of it has been focused on end users, but of course, this is only possible because of the devices that are available on the market. And so for those that are looking to add IO-Link to your product, we have a couple slides here for you. But even if you are an end user, please feel free to stick around for the next few more minutes that we have left, because it shows you kind of how IO-Link gets into a device and what kind of certification these products go through, so that you understand that when you install an IO-Link device in your factory, you can rest assured that it's going to work as it's supposed to, and you don't have to worry about it. So as Nelly mentioned very early in the webinar, competence centers are available. If you are looking to add IO-Link to your device, there are competence centers that can help you with choosing solutions, help you with integrating the solutions. Test systems are available for you when you go to test your device. So these can be acquired, and then you test your device and you sign a manufacturer's declaration, which we'll talk about in a minute. And as we mentioned earlier, there are software stacks available from many different companies for both masters and devices, and the same is true for the chips. These are available from a number of different companies for both masters and devices. So if you need help with any of this stuff, just contact us. This is what we do. This is how we help out. But also on the iolink.com website, there's a really cool competency matrix. And this competency matrix is structured such that on the left-hand side, you have a big entire list of companies, and on the right-hand side, you have their list of competencies. So let's say you're interested in companies that offer software stacks. So you go to iolink.com under Community Competency Matrix, you click on Software Stack, and it filters and displays only those companies that have software stacks available, or chips, or design services, or whatever the case may be. And then it provides a great resource to get you started in filtering on who might be able to help you with whatever you're looking to do. So now you've got, you're working and decided that you want to put IO-Link on your device. How do you go about getting certified? Well, there are two basic models for that. There's a membership model and a so-called license model. In the membership model, you join PI somewhere, anywhere in the world, and by that you're given the rights to all of the IO-Link logos and patents and everything like that. Joining PI anywhere in the world, as Nelly mentioned, we've got roughly 24 RPAs, gives you rights everywhere in the world. You fill out a little IO-Link community form, and they reply with an IO-Link vendor ID. These are managed centrally out of Germany, so we maintain a single database of all the IO-Link manufacturers and their vendor ID, and this helps facilitate the creation of the IODD finder and so on and so forth. In parallel, or after that, whatever the case may be, you begin implementing IO-Link on your device. You get a tester that's available from any number of companies. You self-test, and with that test report, positive test report that says, okay, your device works as it's supposed to, you then sign your manufacturer declaration, and this is what's called self-certification. You take that manufacturer declaration, send it off to PI, and then you get your certificate, and the IODD file ends up in the IODD finder, so that when an end user is in their engineering tool and they want to install your device on their factory, they don't have to go to the IODD finder website and download it and then put it in a library. The engineering tool will just go out to the IODD finder, find it, and import it. The other model is the license model. So in this way, if you're not interested in joining PI as a member, you implement IO-Link, you request a test at what's known as an IO-Link test center. You take that test request, send it to PI, and they'll reply with your vendor ID. You then send your device to an IO-Link test center that's outside of the scope of PI. They reply with your positive test report. You sign your manufacturer declaration and send it all back to PI, where they then will issue a certificate, and you must purchase a license, which is valid for 3 years. And then separately after that, you go acquire the rights to the patents from the patent holders for the IO-Link technology, which in the case of membership is granted to PNO or PI members automatically. So if you're interested in membership, you can join at us.profinet.com/membership/become a member. Fill out that form there. We'll reply and get in touch with you, and then start the process of filling out the application to join the IO-Link community and getting a vendor ID. Pretty straightforward process. And so to find out kind of where everybody is, we've got another poll to do. I'm going to hand things over to Nelly. Nelly, would you like to take it away?
Yes, thank you, Michael, for all that information. And let me launch the poll. All right, so if you are involved in development for IO-Link, so actually making the products, if you wouldn't mind sharing, what is your current development stage? Maybe you're just in the planning phase, or you're currently adding IO-Link to your product. If you're not even, if this is nothing that relates to you, maybe you are an end user, just mark the last option, which is you do not develop IO-Link components. All right, I'll leave it open for a few more seconds. The majority of you come from an end user perspective, but it still is really great to see several of you involved in the development process. All right, so let's finish up this section. Now we're going to jump into the resources and then open up the mic for live Q&A. If you have any questions, just start thinking about them and maybe submitting them through the panel. First, I'd like to share with you a few resources that I thought it would be very useful, especially if you were just getting started with IOLink. The first one is our website at us.profinet.com. We have a ton of information there about the technology, especially in the IOLink technology page. We also have a lot of documentation, so IOLink system description, the system description for safety, some marketing, flyers, and also some additional documentation that is very in-depth. So if you actually wanted to go through those documents, you can download them through our website. And if you're interested in becoming a member, here is the link too. For you to have access to all these links, of course, you cannot click on them right now. I'm going to be posting these presentation and the recording online, so you will be able to access all of these links live. And of course, you can browse our website and get all of those resources, but you can also contact us directly. You have met us virtually, at least today. So please do not hesitate to contact us. Here are our names, and you can contact us through our website or directly. We're going to be sending a follow-up email. So if you want to just reply to that email with any questions, we'll be more than happy to answer them. Now let's open up for Q&A. Let me browse through the questions and then we can select a few of them.
Shall we pick some, or would you like to, Nelly?
Yeah. So let me select a couple. Here's one that came in a bit earlier in the presentation. If multiple devices are attached to a master and they have different speed capabilities, how does the master handle these?
So when the IO-Link device is configured on the via the IODD file and in the engineering tool, at that point, what happens is the engineering tool tells the IO-Link master at what transmission speed and which cycle time it should speak to that specific device. And so that may be, let's say, COM2 every 3 milliseconds. But on the other hand, if there is another device connected to another port, which is often the case, again, when that device gets configured, the engineering tool can tell that IO-Link master, okay, speak to this specific device, COM1 every 10 milliseconds or something. And then so it speaks to each individual device at its own speed and cycle time that's independent per device. But then it's going to have its own cycle time on the field bus side. So maybe you wouldn't want that cycle time to be any longer than the shortest cycle time of an IO-Link device. So if you're speaking to an IO-Link device because you need that super time critical information every 2.5 milliseconds, well then it makes sense to also have on the field bus side a cycle time of that value. The ones that are being communicated with more slowly than that, then you have maybe repeat information that's being sent, which is fine because the information changes more slowly. And so if it's being spoken to every 10 milliseconds, it doesn't really matter that on the field bus side, the IO-Link master is being communicated to every 2.5 milliseconds.
All right, good. We have one more here. Are there any restrictions when implementing different devices from various manufacturers connected to the same master component?
Absolutely not. And in fact, that's kind of the big point of standards like this. You can have any IO-Link device connected to any IO-Link master. That you take it for granted because that's kind of the whole point, is that we want an ecosystem of devices available from many different manufacturers, and that way end users are free to choose best of breed components based on the requirements for their application. So you can choose vendor A device with vendor A master or vendor B device with vendor A master. The interface is standardized and certified such that they will always interface correctly together.
Perfect. A few more questions. Is there any software to read the IODD files?
Yeah, there are IO-Link tools. They're called IO-Link tools. As we mentioned before, often they're integrated into the engineering tool of the PLC, but standalone IO-Link tools are available as well. Again, if you go to that competency matrix on the iolink.com website, that's one of the sections that you can choose, and then you can download those tools. Most of them are Windows-based tools. But again, if you really, really wanted to, the IODD file is just an XML file. So if you had a text editor or text reader that could parse XML nicely, then you could use that. But with the new IODD viewer on the IODD Finder website, that's the most powerful way and easiest way to kind of get an idea of what's inside an IODD file of a device and therefore its capabilities without actually purchasing it or trying to read an IODD file directly. But yes, long story short, yes, IODD tools are available separate from a PLC engineering tool.
All right, perfect. I see a few questions about just the presentation and the recording, if you're going to be have access to it. And yes, to everyone, you will receive it via email, so don't worry. And if you want to share it with colleagues, please feel free. We'll be more than happy to get this content out to more and more people. Besides that, here is a question about IO-Link safety. Is IO-Link safety available right now?
The spec is out. There are system descriptions available. There are also specific integration documents on how IO-Link safety should be integrated with each of the individual FSCPs or functionally safe communication protocols. If there are devices available, I'm not sure off the top of my head. I know a couple of manufacturers, at least the last time I checked was, in fact, a couple of years ago, that were working on this stuff. So I have to imagine by now if not they're available, then it's pretty close. But certainly everything has been spec'd out and companies are working on it. Whether they're available on the market, I'm not sure off the top of my head.
All right, we have a few more. What is the maximum distance between IO-Link devices, for IO-Link devices?
The maximum distance is 20 meters, and that's ironically both the case for wired and wireless.
All right, we have one more that I think we can finish up with. This one, it's pretty general, but maybe it'll be good for closing. What is the reason for using IO-Link and not just use a field bus like Profibus, for example?
Yeah, that's a really good question. The answer has to do, at the end of the day, with costs and the balance between costs and features. So certainly all of the powerful features we're talking about with IO-Link, so all the really rich data and semantics and values and things like that, certainly are all possible with a digital field bus or industrial Ethernet protocol, no doubt about that. What IO-Link does is it splits the difference between just a very simple analog interface, that really complex digital interface, but in a way that's cost effective. Often the costs involved in implementing a digital interface, whether it's industrial Ethernet or field bus, can sometimes be too high for a simple sensor. But that simple sensor also is not so simple, and it's got some extra data that it wants to transmit. And so in this case, IO-Link is a perfect fit because it's very, very low cost to implement, very easy to implement. The hardware and the time effort involved are both very inexpensive or very low. And then it also provides that rich data that you would also be familiar with if you were connecting it via a field busser. So it kind of gives you the best of both worlds. It's a low cost interface, as well as also providing some more of the rich data.
Thank you, Michael. And thank you everyone for all the questions. Now we're going to be closing up the webinar. If we didn't get to your question, please do not worry. We'll just continue contacting you via email. Maybe we need to expand a little bit more if your question is very specific. But thank you again for coming, and we hope you can join us in more webinars in the future.